So again, I want to welcome everybody here to our third webinar in the series on intelligent manufacturing. We are lucky enough to have our Bick Lesser with us today. Now, Bick is the author of the book Intelligent Manufacturing, Reviving U.S. Manufacturing, including lessons learned from Delphi, Packard Electric, and General Motors. And believe it or not, you can get this book on Amazon. So I'm sure that the information that you're going to hear today is going to be compelling. You can look that up if you so desire. Now, what's interesting about what Bick will be talking about today is that we have heard intelligent manufacturing as a buzzword as it relates to the revival of manufacturing in the United States, and that includes the additive manufacturing, which we heard from one of our earlier speakers, which is 3D printing and things of that nature, the plug-and-play factories, machine-to-machine communications, things like that. Now, what Bick will be talking about, though, is from personal experiences, his 30-plus career with Packard Electric, Delphi, and General Motors, is that technology has its place, but it cannot be used as a substitute for good policy, good strategy, and good planning. And what Bick will be going over in torturous detail is what can happen when you forget about the basics and you're looking for that home run pass. So what I'm going to do right now is I am going to turn this over to Bick, and we will get started. Bick, the floor is yours.
Thanks, James. I appreciate that introduction. I appreciate all of you being here and appreciate this opportunity to share some of my experiences and some of my thoughts and ideas that I gained through 34 years directly involved in manufacturing in highly industrialized, highly labor-intensive business. I got my BS in IE from SMU in '71, and I immediately started with Packard Electric, mainly because of the reputation for having an outstanding industrial engineering department. Packard was a vertically integrated company, part of the GM family, one of 26 of the vertically integrated companies. It was a full-service company to supply wiring harnesses to GM. They did all the component design and then made components, made cable, and then assembled wiring harnesses. I was after I was fortunate enough to start in industrial engineering. Again, Packard had an outstanding department. After a couple of years, I went out as a foreman on the floor. What I can tell you is I learned more in that 1 year on the floor than any other 5 years of my career. I learned more about the business, about managing people, about the importance of controls than I could have ever learned anywhere else. A few years later, I was asked to be part of the initial startup team for our Mexican operations. We started a plant up in Juarez, Mexico. It was supposed to be one plant of 800 people. Several years later, it was 26 plants with 50,000 employees. In '81, I was given responsibility, engineering responsibility, for starting up the very ill-advised Mexican supplier program that I'll touch on later. In '84, I was given engineering responsibility in Portugal for our new Portuguese plant, which was the low-cost supplier to Rheinsagen, which had been purchased by GM. It was headquartered in Germany. In '87, I was asked to take responsibility for the operations of a new joint venture that we started up in South Korea, supplying wiring harnesses to Daewoo Motor Company. After that, I came back to the States. I worked in Mexico, the Mexico East area that had started up when I was overseas, and I had various engineering and manufacturing responsibilities there. Next slide, please. In 1977, I was assigned as the manager of the Packard Hughes Interconnect operations in Foley, Alabama, where we made electronic components and aviation wiring. And one of the things that I learned very, very clearly, and Packard should have learned, is that you do not get into businesses that you do not know and that you do not understand. In 2000, I was transferred back to the Mexico West operations. By this time, I had become extremely disillusioned within Packard. What had once been an outstanding manufacturing company had disintegrated. I had an opportunity for an early retirement, and I took it. I spent the next 4 years consulting for Lear Corporation, who was also a automotive component supplier, primarily in the seat business, but they were also getting into wiring harnesses and wanted to grow and develop that company. What I consulted in both areas, and what I clearly understood and actually knew before that, is that the fundamentals, the tools, the concepts of good manufacturing are transferable from one company to the next. They may need to be tweaked or varied, but the concepts are going to be very viable. After taking a little bit of time off, I started thinking about my career, and I realized that because of my unique experiences in manufacturing and engineering in a number of locations inside and outside the country, that I had some things that I really needed to share. I had seen the best and the worst in manufacturing. I had seen some brilliant things done. I had seen some very foolish things done. I had the opportunity in some of the jobs that I had been assigned to develop some tools that solved problems that Packard had that they never seemed to understand, that those kind of tools were things that they needed rather than looking for the silver bullet, that they kept searching for them. What is intelligent manufacturing? I talk an awful lot about it in the book, obviously. Just to hit a few highlights, the main thing is just don't do stupid things. Packard did an unbelievable number of really, really dumb things that should have never been done if they'd have followed the basics of good, sound manufacturing. You need to have unwavering attention to proven basics and best practices. You need to learn from the success and failures of others. It's too costly and too time-consuming to make all the mistakes yourself and learn from them. Learn from others. The absolute critical need to have well-designed and developed scientific tools to use as a means to an end, not as an end in themselves, which is what Packard did in many, many cases. And certainly to justify any change based on using scientific tools and based on tangible savings, and not to have change for change's sake. Now, I'm only going to be able to touch on scratch the surface of what I've got in the book and the details that I provide there on way of the different examples of things that Packard did well and not well as the tools that were developed. But hopefully I'll be able to touch on some of these that will pique your interest. Now, the reason I wrote the book was that I was very concerned. I'm a very patriotic American. I was very concerned about the status of U.S. manufacturing. We were bleeding jobs by the tens of thousands every month. They were leaving the country, and they weren't coming back. Now, apparently, according to what Jim said last week, there has been a resurgence because of intelligent technology used in manufacturing, and some jobs are coming back, which is great. But if we do not do the other smart things to control manufacturing, it will not be a lasting success. Strong manufacturing base, I think all of us understand, is absolutely critical to not only the economic viability, but the security of the United States. I think we all understand, we know history, that 2 world wars were basically won because of U.S. industrial might. I was also very concerned about China. Back when I wrote the book, we were still ahead of China in both manufacturing and our economy. I understand that those things are now gone the other way, and that is a very troubling prospect. Now, the reason we lost all those jobs, obviously, is because of a deteriorating U.S. competitive position. It could certainly be and has to be a lot better. The problem is that there's really 2 phases here. One of them is there's a lot of problems that we have makes us non-competitive that require a political solution, and we have not had people smart enough in Washington to understand things that need to be done to help our manufacturing base. Obviously, we face an awful lot of unfair trade practices. We've got the 2nd highest corporate tax rate in the world. National preferences and prejudices are certainly exist in many of with our trading partners. We've had an energy policy that I don't know that anybody can fathom. not developing the unbelievable resources that we have. We have a business environment that is way too heavy on regulation and red tape. We also have a workforce that's not where it needs to be. Our public school system, since the inclusion of the federal government and into that system, has gone steadily downhill. Those of us that went to school prior to the Department of Education and federal involvement know that our school systems, public schools at one time, were the best in the world, and now our students lag far behind. There has to be some changes there. The other thing that we've never done a good job of is provide technical training, apprenticeships, and so forth. There's a lot of kids that in high school age that are just not cut out for college, and if they could get technical training and apprenticeship training, it would be a tremendous boon to our manufacturing base. It's done in countries like Germany very, very successfully. The other area is where we need U.S. companies to step up, and that is to improve the desirability, the quality, and the cost of U.S. goods. And this is really the focus of my book, and I go into great detail in a lot of areas. As Jim pointed out last week, the U.S. does have some very significant built-in advantages. Logistics and transportation are right at the top of the list. Of course, infrastructure. We have infrastructure that most countries do not have. Technology and innovation is still a very strong ingredient in the United States. Energy availability, if we exploit it, is unsurpassed in the world. And certainly the risk of doing business in the United States is nowhere near the risk of doing business in most other countries. The security of personnel and intellectual property is certainly very strong in the U.S. Now, I'm not, during this presentation, I'm not going to talk much about GM. I do talk about them quite a bit in the first couple of chapters in my book, but I'm going to focus on Packard. Packard, in 1971, when I started, had one thing that was very strongly against it, and that is that it had one manufacturing location. It was a headquarters and where everything existed in northeastern Ohio, very heavily unionized, very strong union, paying UAW wages. Most of our competitors were paying non-union wages and in small shops scattered around the world, even in the United States in low-wage rate areas. However, it had some things going for it. It had some outstanding manufacturing processes, systems, controls in place that had been developed over many decades. It also had an outstanding industrial engineering department with the methods lab that developed the best manufacturing systems for wiring harnesses in the world, and had an outstanding training programs in addition, had an outstanding process lab. But the most important thing was that the control of direct labor was unsurpassed. I've been in many, many plants, wiring and otherwise, and I've never seen anyone that had the kinds of departmental organization and the control systems in place that we had at Packard. There was also an unwritten policy at Packard, at least I think it was unwritten, but it was followed virtually without exception, and that is to get into the upper levels of GM management, or in this case Packard management. The individuals would need to have gone through engineering, preferably industrial and methods engineering, and manufacturing at the lowest levels. This would ensure that they knew the business, that they were grounded in reality, that they could make good decisions about the business based on knowledge and not on textbook information or hearsay. That policy, unfortunately, was disbanded in 1977 because of EEOC pressures, because there just were not enough females and minorities with that kind of a background, so that no longer became a prerequisite. And it didn't happen overnight, but over time there was certainly a dilution of the abilities in the upper levels, not because of intelligence or knowledge, but because of experience. In the early 70s, as I said, Packard was really an outstanding manufacturing company. At that time, Toyota was just a blip on a radar screen. Nobody knew who Toyota was. They had their core principles at that time, I'm sure, but nobody had ever heard of them or knew what they were. Packard certainly didn't know what they were. And just to kind of analyze how Packard was doing, without knowing what those core principles were, but evaluating them against them. I went down through all 14 of them. I've done it in detail in the book, and I give reasons why I gave each one of these evaluations. But in 1971, I would have given them 2 A's, 7 B's, no C's, 4 D's, and an F. Now, 4 D's and an F don't sound very good, but the first couple of years at Packard was when we first started chasing rainbows in the early 70s. If I, based on everything that I was able to understand and gather, that prior to 1971, if we would have done an evaluation, that the scorecard would have looked significantly better. 2 A's, 10 B's, 1 C, and 1 D. I think you would have to say that we certainly had a passing grade, particularly when we didn't know that there was a test or that there was a scorecard to be measured against. Now, Toyota also had the Toyota system rules. We obviously didn't have those either, but we would score equally well on those. Next slide, Jim. Or James. We would have had 1 A, a C, and 2 B's. Again, a passing grade and pretty solid when you don't know that there is something out there you're going to be measured against. As I said, the overall operations were very efficient, but because of the union situation and because of some unbelievable decisions made by management, we were very non-competitive. Basically, you can say it boiled down to the selfishness and short-sightedness on the part of both union and management. At that time, we came under tremendous pressure from GM to slash prices. GM was starting to lose market share to Toyota, to all of the Japanese manufacturers, particularly after the oil embargo. Next slide, Jim. James. And basically after the 94 oil embargo, panic ensued. I don't think there's any other way I could describe it. It was something we always said in engineering, which is absolutely valid, and that is, without data, you're just another person with an opinion. And everybody would have accepted that in 1971 and before. The way things started transpiring in the early 70s, we had to add the second part of that, unless, of course, you are at a level where your opinion becomes data. Well, I think all of you can understand how dangerous that is, but that's exactly what started happening. Packard started looking for this magical silver bullet, something that was going to make us competitive in Warren, Ohio. Most of the people had their roots in Warren, Ohio, wanted to see Warren remain viable, and so we were looking for that silver bullet. In the process, the eye was taken off the ball. Focus was taken off of the tried and true basics. Next slide, James. The first thing that Packard did was delve into automation or semi-automation. Anybody that knows anything about wiring harness design understands clearly that wiring harness does not lend itself to automation or semi-automation for that standpoint. Without major changes in product design, it will never be such. They tried 3 different major attempts at automation or semi-automation, none of which I would find fault with from the standpoint that they were doing analysis and looking at possibilities and trying to develop technologies that might pan out. The big problem that I had was that none of these systems were ever validated in the methods or process lab or in a pilot area or anywhere else before they were put into the plant. That's a direct violation of one of the most critical principles of Toyota. And what it led to, as you might imagine, was just absolute disaster in the plant. From my perspective in analyzing what was being proposed, there was never any economically justified reason to put these systems in, even at their lofty projections. The second one that was put in, the IPS Phase 1, because of the big failure we had there, I created a new concept called the economation concept, and basically what that says is if you have a system with a lot of expensive components, each one of those components, if it can be separated out from the system without penalizing the system, need to be justified on its own merits. If that had been done, IPS Phase 1 would have never been put in place. A system that was supposed to save $250,000 with a $220,000 investment sounds pretty good, but when you understand that one aspect of that system cost $200,000, and the very, very rosy projections were that only 10,000 savings would be attributable to it, you understand what a horrible decision that was. None of these systems ever ran anywhere near close to what was projected. The IPS Phase 2 lines were expected to run at 95% plus. How that was ever possible, understanding that if you took the uptime of each of the processes on the line and multiplied it by themselves, you would never get, in best case, more than 80% uptime. Because the line never ran over 70, a lot of those individual processes were never even ran that well. But the fact that they were put into the plan is bad enough, but the decision was made to not scrap these after first failure and before they were debugged or had any chance of viability. They were proliferated. There were an additional 15 lines of the IPS Phase 1 put in place, an additional 5 lines of IPS 2 put in place. It cost the corporation millions and millions of dollars, and this was money that Packard did not have at that time. It's certainly okay, and it's something that needs to be done to look at new technologies and look at new developments, but it is not okay to take systems that have never been debugged and proven and put them in the plant, and it's certainly not okay to proliferate them. At this time, Packard was really grasping at straws, and the next idea was to create a supplier program in the United States so that we could contract suppliers that paid lower wage rates and have them build harnesses for us and then buy them back, and of course would be supporting them, providing an awful lot of technical assistance. Well, I don't think there was ever any economics, positive economics involved with this. If there was, we might have saved a few bucks. But the question is, with the risk of losing control, we did lose some good employees. We created some competitors. And of course, the biggest risk of all, what would GM think? Why, if somebody else can build their product and they're capable of doing their own design work, why do they need Packard? Well, those are some of the really foolish things that Packard did. They did a couple of really smart things next. At least they started out smart. One was a strategy, what I'll call the Southern strategy. We built 3 plants in Jackson, Mississippi, outside of Jackson, in a low wage rate area, which was smart. It was something that Packard had to try to do because they could not be competitive in the North. The union was not going to make concessions that needed to be made. The problem was that they did not take with them the proven concepts that had been developed over decades. They started up with a new concept on how to handle cutting and lead prep in these operations. It was never validated, never proven anywhere. It was just thrown into the plant. It was an absolute disaster, and we were on the verge of shutting down General Motors assembly plants over a period of many weeks through Herculean efforts on the part of an awful lot of people. Things finally got turned around after that initial concept was scrapped and we went back to the tried and true basics. But again, this is something Toyota would never do. You'd never put anything in the plant that had not been validated. They did install a methods lab and did a very, very fine job in their methods lab, but they did not transfer the outstanding manufacturing organization basics that had been developed in Packard. So the productivity in the Mississippi operation was never what it should have been. And unfortunately, in the late 70s, wage parity was given in order to try to avoid the union, and that basically was the beginning of the end for the Southern strategy. If that had worked, Packard would have continued to expand in the South, and there would have been an awful thousands and thousands, tens of thousands of good manufacturing jobs in low wage rate areas, but that was not to be. The next strategy was absolutely necessary. It was a very smart strategy, and that was the strategy of going to Mexico. It was absolutely necessary to survive. GM got an awful lot of criticism, or Packard, for this move, but there was no alternative. Without this move, Packard would have been bankrupt long, long earlier. unfortunately, it was necessary because unions were not willing to make necessary concessions. Management kept making an awful lot of mistakes. And the problem was that when we went to Mexico, we did much the same as we did in Mississippi. We did not transfer the outstanding organization basics and the outstanding control system in manufacturing that we had in Warren, Ohio. The reason that I kept hearing as to why we didn't do that was that Mexican labor is cheap, and so we don't really need to worry about it that much. Well, the problem is that Mexican direct labor was far and away the most expensive cost component in any plant operating report. 70% of a plant operating report is labor, 70% of that is direct labor, so there's a half of the total cost in the plant on operating report, excluding materials, which basically get charged the customer and not an expense in that sense. And the other thing to note is that virtually every other line item in a plant operating report is directly associated with how many direct operators are in the plant. So I don't care what your cost per hour is. I don't care if you're in China or Mexico or where you are. If you do not control direct labor, you are going to have big, big problems. The next thing I alluded to earlier a little bit was the very ill-advised Mexican supplier program. I argued vociferously against this program because it never made any sense economically. The suppliers had exactly the same cost structure we did. Basically, Mexican governments established the minimum wage, which everyone paid, and of course our suppliers had to make a profit. So the numbers I saw were that it was costing us $2 per standard hour for every harness that we bought back from our suppliers. Absolutely absurd thing to do. And of course, there's an awful lot of risk involved with the supplier program. I was actually asked to be the engineer, heavy engineer responsibility for developing this program. As irony would have it, we started the program very successfully, but we did start up some competitors. We lost some money, and it was a foolish thing to do. Packard realized at this point that they were going to have to do more than be just a North American company. The next foray was into Europe. Rheinsagen was purchased, and Portugal was the low wage rate area in Portugal. I was asked to have engineering responsibilities there. We did start up a methods lab and put in place some of the other basics that I've talked about and will talk about, but they never really made it out of Portugal. Then Packard went on to what I'd call the world strategy. It started in Korea in 1986 with our joint venture, which I was asked to have operational responsibility for. And of course, there we did introduce all of these concepts that I'm talking about and all of the basics. But I left there after 4 years. I think things gradually disintegrated after I left, and they were never implemented anywhere else. The bottom line is that Packard in the early 90s tried to become, next slide, James, tried to become Toyota. The problem is that they did not have a clue as to what needed to be done. Packard thought that all of these tools, these gimmicks, I'll call them, that Toyota was using, the Kanbans and quality circles and Poka-Yokes and all these other things that you're familiar with, was what made them successful. Well, it was a 4-year study done by 2 gentlemen. They wrote a review for Harvard Business, and they had spent 4 years inside of Packard, or inside of Toyota, understanding what Toyota really did. And they wrote something. They know more about Packard or about Toyota than anyone else that I had ever observed or heard. Basically what they said is, the truth is that Toyota does not consider any of these tools as fundamental to the TPS, or Toyota Production System. Toyota uses them merely as a temporary response to specific problems that will serve until a better approach is found or conditions change. Well, that's exactly opposite to what Packard did. Packard used those tools as an end in themselves, and as a result gained nothing, no benefit whatsoever from them. Matter of fact, giant penalties as you analyze things that transpired, and as I spell out in the book that I wrote. They also created Packard in honor of Toyota, I suppose, a Packard production system. It was patterned after Toyota Production System, but again, there was a big misunderstanding of a lot of what Toyota was actually saying. The biggest one was a misunderstanding of characteristic number 6 of Toyota's ideal manufacturing system. which says can be delivered one request at a time. Well, Packard's interpretation of this was that that means that the optimum batch size is one piece. Well, if you know anything at all about wiring harness manufacturing, you know that is an absolute absurdity. In cutting and lead prep, a batch size of one is ludicrous. The only place where it makes sense is in final assembly, where there already is a synchronous one-piece flow. I tried to get that principle restated. It was stated a single-piece flow is the least costly method of providing value, which is absurd. I tried to get the words you see there in parentheses, in final assembly process, generally, and then I pointed out what those final assembly processes were. Unfortunately, that was never accepted. The reason was that they didn't want to dampen anybody's enthusiasm about one-piece flow. And so there were some horrific examples of things that Packard did because of that misunderstanding, again, that are spelled out in detail in the book. The other thing is that he did not understand Toyota's 7 forms of waste. I think everybody knows what they are. See, we got them there, okay. You've all seen these before. The problem is that Packard believed those to be mutually exclusive. The problem is that they are not mutually exclusive. They're interdependent, and if you make a change in one to enhance or improve one of those areas, you could very well be creating an offsetting deprovement in another area, or even more than offsetting. The other thing is that Packard never understood an 8th form of waste that Toyota also did not ever mention, and that is the underutilization of resources, and that's both human resources and capital. If that form of waste is understood and added to what Toyota includes, a lot of decisions that Packard made would have been made dramatically differently, and I think other companies as well. Bottom line is that Packard pretty much became a sucker for every new concept that came down the road. It was always, is this the concept, is this the one that's going to make us competitive overnight? They often misunderstood and misapplied these concepts. Again, tried to make the concept an end in itself instead of a means to an end. Started listening to a lot of experts, many of which were in academia, had no on-the-floor experience, no first-hand experience, a lot of theory, much of which is not practical. The bottom line is that you have to be very, very careful who you benchmark, who you listen to, make sure you're doing things that make sense. Well, Packard failed miserably in their attempt to become Toyota, as you might surmise by now. John McElroy, who followed the automotive industry very, very carefully, wrote something that's spot on, very intuitive, that should have been obvious to everybody that had anything to do with GM and Packard at that time. What he says is, American companies don't seem to have the discipline or attention to detail needed to grind out consistent annual improvements. They can do spectacularly well for a while, but ultimately succumb to distractions when management gets bored with consistency and starts dreaming of breakthrough programs that will leapfrog the competition. Toyota and Honda still lead everyone else because they stick to what works and consistently improve it. They're not smarter, they're not better, they're simply more consistent. As far as I'm concerned, the very epitome of intelligent manufacturing. Well, so how did Packard do, going back to that same scorecard against the 14 Toyota core principles? In 71, or I'll go back before 71, 2 A's, 10 B's, a C, and a D. In 2001, after having the scorecard and trying to become Toyota, no A's, no B's, 5 C's, 8 D's, and an F. They didn't do much better on the Toyota production system rules, where we had an A, 2 B's, and a C in 71. In 2001, no A's, no B's, 3 C's, and a D. Someone might ask, how in the world could this happen? How can you digress so badly, particularly when you've got the template there to follow? Well, it all boils down to a lack of good leadership. There became a tremendous concern about finding that silver bullet and recognizing people for being innovative and creative, and total lack of focus on the things that were really important, on productivity and effectiveness. Not that we shouldn't be looking for technological improvements, obviously we should, but you can never back away from those basic principles that what is going to make or break a manufacturing company. Packard quit using scientific tools and best practices which had been developed over decades. They quit using scientific tools. They misunderstood and misapplied many new concepts. Bottom line is they basically lost confidence and started listening to the wrong people instead of the people that knew the business, because there still were some there at that time that still did know the business. After going through this, I said, well, what can I do to help? I can talk about what Packard did wrong and the things that were done right, but there are some other things that I learned, and I call them universal truths and eternal truths. These were true 100 years ago. They'll be true 100 years from now. The first is that the greatest success will be achieved through leaders and not managers. If some of you have not read Good to Great by Jim Collins, I would highly recommend this book. He validated through very, very careful studies what I had observed and understood to be true during my 34 years in manufacturing about leaders versus managers. But basically, if you want to identify a level 5 leader, you look for an area or a company where there are extraordinary results, but nobody steps forward to claim an excess credit, and there's a level 5 leader at work. I won't go over all the different characteristics of level 5 leaders. I'll just use the last one and say if you want to know what a level 5 leader is, you consider the person we have occupying 1600 Pennsylvania Avenue and imagine the polar opposite, and you will nail what a level 5 leader is. The other part of this is that there's a need to identify empty suits, as the current term for it. It's those that are all show and form and no substance. John DeLorean collaborated on a book called On a Clear Day You Can See GM back in '79, and he had become very, very successful within GM, had become the Pontiac general manager, had other very prestigious positions, and he wrote a couple of things that are very telling. So if executives within GM who rise to the top are not the best managers, but those most skillful in flattering their bosses. A system which puts emphasis on form and style and unwavering support for the decisions of the boss almost always loses its perspective about an executive's business competence. Anybody that worked at Packard during the years that I'm talking about would say amen to that in spades. Next slide. Another universal truth is that what you do not measure, you do not control. I read this in a magazine one time, and it hit me like a ton of bricks, and I said, this is absolutely true. And I added to that, when you measure performance, performance improves. When you measure and report performance, performance improvement accelerates. As I've already stated once, if you do not control direct labor, it is highly unlikely that you will control anything else, whether it's quality or delivery or anything else. Direct labor is far and away, as I've already stated, the most expensive cost component in any manufacturing operation that has any significant amount of direct labor. And if it is not controlled, disasters will happen. One of the things I put up here to help understand what Packard went through, the different phases they went through, is this chart here. In 1971, when I started, I would put our productivity in manufacturing, control of direct labor, at world class. You can see 4 circles there with 4 major events that occurred that dramatically decreased that. The first was the failure to implement operator and process efficiencies in Mexico and Mississippi, I believe, as well. So there was no way to understand productivity down to the operator or to the process level. The second thing that happened at the same time was there was an improper manufacturing organization implemented in both in Mississippi and Mexico, and that's that big drop you see. Continued slow decline until another big drop with .3, their introduction of remote cutting and lead prep to Mexico. Absolutely the most non-synchronous, ill-advised concept that one can conceive of. Had a tremendous negative impact on our productivity. Lines were down constantly because of the 2,000-mile pipeline of getting cut leads to the manufacturing plants. Absolutely a terrible decision that was made. The fourth would be the elimination of the routings, or I renamed them the direct labor Bibles, and I wrote an entire chapter on this and detailed how the system should work and how it can be computerized to give you the tool that you need. And they, with that, went away the production efficiencies in North America, which was really the only tool left at that time to have any kind of, create any kind of reasonable comparison between operations or really know how effective we were operating. In addition to that, there was kind of a general downtrend due to increasing management weakness. Again, I think largely because of the lack of IE and manufacturing experience and taking focus off the basics. Next slide. I also devoted a chapter on computers. Computers can be a godsend or they can be a real problem in any company. Companies that think that they're going to be able to buy computer programs off the shelf that are going to give them a competitive advantage are very mistaken in 99.9% of the cases. If you want to get a competitive advantage, you are in almost all cases going to have to design the systems that you want, the reports that give you the data that you need, and you're going to have to determine where that data comes from and make sure that it gets into the system. But expecting to buy something off the shelf is not going to work. Just to emphasize the importance of data, I want you to imagine professional sports today, and imagine if there were absolutely zero statistics in any of those professional sports, maybe not even including won-loss records, and at the end of the season people just voted on who should be in the playoffs. Imagine the quality of the game after a relatively short period of time. Well, that's what happens to the quality of manufacturing if you do not have the data that you need to put the controls in place that are necessary to run. Packard never introduced the process and operator efficiencies in Mexico, got rid of production efficiencies. It was determined based on a meeting that I held with the managers in Mexico West that if those procedures, if those systems had been in place, it would have meant $50 million on a yearly basis to Mexico West, or to Mexico West and East. It would have cost a few $100,000 to implement it. Another universal concept is that people will do what they are motivated to do, or said another way, you will get the performance that you motivate. The laws of nature will not be violated. If you want to be successful, you must reward good behavior and punish bad. If you do the opposite, the results are absolutely 100% predictable. Next slide. In this slide, I show the characteristics of paced versus non-paced jobs. Paced jobs are the conveyor lines. 80% plus in the final assembly areas of hours got shipped off of the paced jobs. But the paced jobs, looking at the characteristics, they were very easy to learn, very easy to become proficient, easy to control from productivity and quality standpoint. Successive verification was easy. From a desirability standpoint, they were not desirable at all. They were much less desirable than the offline jobs. Well, the Mexican supervisors, left to their own devices, decided since most of the production was coming off the pace lines, that's where all the very best people were going to be sent. So the reward for being an outstanding operator was to go to a job that was the least desirable in the plant, and the punishment for being a very poor operator was to be sent to an offline operation where you were not controlled and basically you could pretty much do what you wanted. The bottom line is this: when you reward poor performance and punish good performance, the outcome is 100% predictable. There are many cases where companies get themselves into this quandary. Next slide. Well-designed scientific tools are absolutely critical to improve manufacturing performance. Now, that is a universal truth. All new projects and programs, as well as changes to current systems, processes, or procedures, must be designed, developed, and be debugged and justified through objective scientific analysis. Again, a key Toyota principle. The chief among these in Packard was pre-planning. Pre-planning, which includes lab simulation, is the best tool that I have ever seen for developing an entire manufacturing system. and optimizing virtually every single aspect of that system. Unfortunately now Packard is just a shadow. It still does some pre-planning, but it's just a shadow of what it once was. Next slide. I put this slide together to give you an idea. Next slide also, James. I put this slide together to kind of visually depict what happens when you go through a pre-planning process for a final assembly conveyor. You see at the very bottom the minimum labor content line. Well, obviously when we go into production, we want to be as close to that as we possibly can. From when you pre-plan in the methods lab, the starting point could even be at that line. If it's above it, it's not going to be very much above it. And with over time, with some continuous improvement, it will hit that line. When you start out with a job that has not been pre-planned, what is done in Europe and most other companies is engineers develop a production plan sitting at their desk using standard data. You are going to start out at a point way above the the minimum labor content, and over time you will get some improvement, but you'll never get anywhere near the minimum labor content line, because there are limitations and restrictions on what you can do on manufacturing systems that are currently in production. So again, I cannot overemphasize, and there's an entire chapter on pre-planning, which is a universal concept that can be used in any type of product. Next slide. One of the tools that I had the opportunity to develop, I named the key activity control. I had been through an awful lot of exercises at Packard where we were trying to find ways of reducing the total process cycle time. Probably all of you understand what that is. You understand what a value stream is. What Packard always tried to use was value stream mapping, assignment of task forces, Six Sigma projects, and so forth. I put that all of those have limited value. I would go further to say that none of them ever accomplished anything. The only tool I've ever seen that has accomplished anything in this area is this key activity control, where we actually did reduce the total process cycle time on several major projects by over 80%. One being on Mercedes prototype harnesses, where we were about to lose a business because we were so delinquent in getting prototypes to them. The other was on implementing engineering changes on the F-car, and they were also, we had a very unhappy customer. Without going into details, just very quickly, we use the concepts that people will do what they are motivated to do, and if you do not, what you do not measure, you do not control. In designing this system, what you first have to do is define the critical value stream, assign the responsibility for accomplishing each step in the value stream, design a key activity control chart on which then record performance on this chart as each step is completed. What you find is that human nature kicks in because people are being measured. They know they're being measured. They know the report is being generated and sent out. The time to complete each activity is driven to the absolute minimum. What happens is that people will start on their activities before the prior activity has even begun, so that as soon as the prior activity is completed, their step in the process can be completed as quickly as possible. Of course, these are easy to set up. I did them on Excel spreadsheets. They can certainly be done in a more complex manner, but it's very easy to do all automatic calculations on these. Packard did not only not expand this concept, they didn't even maintain it where it had been put in place. Another universal truth I want to talk about is that sub-optimizing can be a very, very expensive proposition. The way I define sub-optimizing is optimizing one element in a system without consideration of the impact on the other elements in the system. It's very closely related to the economation concept I talked about. The two things that were consistently sub-optimized in Packard was salary, headcount, and inventory, I think in large part because those are the two things that managers tend to understand and be able to get their arms around. Invariably, when we reduced headcount on a short-term problem or short-term pressures, it resulted in big problems. There were always plant problems that resulted because of not having people that were needed, and it resulted in hiring more expensive and less qualified people a short time later. And of course, you can imagine what it did to the morale of the people in the plant, particularly when we had Packard principles about how important people are valued and appreciated. Inventory is the other area that is notorious for being sub-optimized. The problem is that when Packard gave dictates on inventory, they were never accompanied with systems changes that what might have made that possible. Getting rid of remote cutting and lead prep would have made the 25% in annual inventory reduction a piece of cake, but that was not allowed. Basically, it had to be done through grit and determination. On a White Isle tour, it was part of a lean manufacturing tour. Sometime about a year later, the manager of materials was giving a presentation to this lean group, and he said, you know, I've got some good news and some bad news. The good news is that we met our $25 million inventory reduction goal, which took a couple $1 million at that time to the bottom line. The bad news is that the premium freight increased $2 million or $10 million due to missing material and shortages of material. I told him at the end, I said, you only got it half right. I said, we lost another $10 million due to productivity losses because of line downtime because of missing material. You can also imagine the rippling effect, the negative attitudes that this created throughout the organization when these kind of things happen and people know that people making decisions don't have a clue. Insanity, these two things kind of remind me of one of my other famous, most favorite sayings. Insanity is doing the same things you've always done, the same ways you've always done them, and expecting that the results are going to be different. Next eternal truth is that continuous improvement should not and cannot mean continuous change. Slow and steady progress is a key. And you'll get to the point on some processes where you reach the optimum, the minimum labor content that is possible, and just maintaining that is going to be a difficult challenge. Often it's more difficult to stay at that level than it was to get there in the first place. Packard managers, everyone within Packard was constantly challenged to be innovative and creative. Nobody was ever rewarded on effectiveness or productivity. People took the cues, and the results were very, very predictable. The importance of standardization cannot be overemphasized. Every plant started looking different within Packard. There was no way, because the tools to control manufacturing had been lost. There was no way to compare plant to plant. Again, it was very predictable what was going to happen. Now we're to the last slide, and again, it's a universal truth, and that is to correctly establish the optimum lot size, scientific tools and calculations must be used. Because of lean manufacturing efforts, everyone is trying to push their cut quantities or cycle quantities to the lowest possible level. Packard thought it ought to be one piece. I kept asking the question, why? Where are the economics? The answer was always, well, we are going to become so efficient that it'll just happen. We'll become efficient. We'll save this money, when no economic justification could ever be shown for that. I put in place a system to scientifically calculate how the optimum lot size should be calculated. It's a relatively simple thing to do that I did on an Excel, or did on an Excel program. First of all, you need to understand that in any system there are basically two buckets of cost. There's one bucket of cost that decreases in cost as the cut quantity or cycle quantity increases. These are costs associated with operators, pieces of equipment, floor space needed by them, support for them, and so forth. The other cost bucket are costs associated primarily with inventory that increase as cut quantities increase. Well, if you plot these two curves at different volumes, at different cut quantities or cycle quantities, they will intersect at a point. If you then make a curve that is an addition of those two curves, you'll come up with a final cost curve for that operation for the department on a yearly basis. Where that curve flattens out, which normally is going to be fairly close to where those lines intersect, you will have the minimum cost point for your cycle quantity calculated scientifically. I've got an entire chapter on this as well. In the operations in the Philippines, I use this concept to help them go from a point of having to work considerable amount of overtime and having a project in place to have to buy 20 additional cutters to a point where by increasing their cycle quantity scientifically, they freed up 20 cutters and got off of overtime. So bottom line is that we need to use scientific tools to make those kinds of decisions. Well, I appreciate the opportunity I've had to speak a few minutes to all of you. Hopefully I've said a few things that have piqued your interest. Again, there's a great deal of detail that I certainly can't cover now that's included in the book, as well as exactly how each one of these tools worked. There is no silver bullet out there except for the silver bullet of adherence to the basics and the principles. And when you introduce new technology, do so in a common sense, reasonable way, validate it and justify it, and debug it before it's implemented. And if we ignore the universal principles that exist of good manufacturing basics, we will not be successful in the United States, regardless of how good our technology is. So, Jim, with that, I will end it and open the floor for questions.
Well, Bick, thank you very much. That was actually indeed in-depth, detailed, and informative. The floor is open. If anybody has any questions that they would like to ask, now is the time to do it. We will be mindful of everyone's time. We did say that this would be an hour-long presentation, so we got about a couple minutes. When looking at this last slide here, when you were talking about the OLS on the optimum lot size,
correct.
What does that mean?
It means determining what lot size will give you the most economical quantity in a manufacturing process. What Packard started doing was pushing to get down to 1 day's cut quantity, for example. Of course, they wanted to go well past that. And the question was, well, why? Where are the economics to show that this is the right thing to do? Well, the economics don't show it. I put this system together, this matrix, to evaluate what that optimum quantity was. And in most, it'll vary from plant to plant, depends on the volume and type of product, some other considerations, type of cutters and so forth. But normally that volume is going to be several thousand pieces, which may be 2 or 3 or 4 days for high volume harnesses. It may be a week or 2 weeks for some of the lower volume harnesses. But it needs to be calculated scientifically and not by holding your finger in the wind or by reading a statement that we need to drive cycle quantities to the lowest level to be effective. One other thing I'll mention is that I think, words are very important, I've come to understand. And we used to call, when we processed many pieces at a time, it was called batch processing. Well, batch processing got to be a very, very unpopular word. I believe that if we have called it optimum lot size processing from the get-go, we would have never had a lot of the problems that we ended up with, because I think it would have had a different connotation, and we said, okay, well, we're doing it the optimum way, so that's great. So that's what that means.
Okay. Okay, if there are not any more questions, I mean, now it's time. You've got the question box. Just entered the questions in now. When you also were mentioning on the direct labor costs,
Right.
particularly as it dealt with in Mexico and other places, there was a variety of terms you were using. Could you go into more detail on what exactly was entailed in direct labor and how that differentiates from any other of those labor costs?
Well, direct labor, is the way we defined it at Packard, was that anybody was working hands-on on building the product. I think a better definition is if you can come up with if you can quantify a standard for a person doing work within the plant so that they can be put on what I call a direct labor Bible or on a routing, and you can establish a productivity level for them, I would consider that direct labor. For example, the service people that we had in the plant were not building directly onto the product. They were putting materials on the line, but they were considered direct labor, as were the repair operators, the inspectors that were at the end of the line were considered direct labor. The auditors that were in the plant roaming and doing auditing work were considered indirect, and they were considered in the budget. The bottom line is that you need to control hourly labor in the plant, whether you do that through an efficiency system, whether you do it on the plant operating report through the budget. Somewhere, some way, you need to control direct labor, and the more closely you control it, the more successful you will be. Again, that is by far and away. In Mexico, as I said, probably, if we really had a 100% accurate analysis, probably at least 60, if not 70% of the total factory cost, excluding materials, which is really in a separate category, but of everything on the operating report, probably 60, 70% were direct labor related.
Well, once again, Bick, I want to thank you very much for your time and sharing with you your insights and experience, as well as the putting all this down on paper for other people to look into and learn from those mistakes. With that, I want to thank everyone again for spending the hour with us today. This will be recorded, so you will also get a copy of this tomorrow that you can either share with other colleagues that you find interesting or for yourself. So with that, we are finished up. We have another one next Thursday, which is a Q&A session with Daniel Abadowski on the Internet of Things. We'll keep an eye out for that. With that, we are good. Everybody have a great day. Bye.
Jim, you there?
Yeah, we'll talk offline.
Okay.
All right.
Well, hopefully